Alright, level 5.3, solving trig equations. As we do this, it might be a good idea to have out your unit circle, okay, as we do these equations. Now, there's a few different things you should look for, and also on how to simplify them, we'll go through. Here's one of the more basic ones. It doesn't look that basic, but with some of these, you're going to do one of two things. One of those things would be to isolate your trig function. So I'm going to isolate sine. So subtract 2 sine from both sides. 2 sine x equals root 2. Divide by 2. Get sine root 2 over 2. Now, where on your unit circle is sine equal to root 2 over 2? That would be at pi over 4 and 3 pi over 4, right? So and it's not just those values, right? It's going to keep hitting at pi over 4 over and over every 2 pi. Add 2 pi n. And then I'm going to include this little symbol here. Which all that means is for all integers n. Okay, so assuming that all throughout they are integers. Okay, so 2 pi n is added to that, and we're assuming that n is an integer. Once again, same strategy applies. Let's isolate our trig function. So we'll subtract 4. 3 cotangent squared x divided by 3. Get cotangent squared x equals 1. Square root. You're going to get cotangent x equals plus or minus 1. So where is cotangent equal to 1 and negative 1? That would be at pi over 4, 3 pi over 4, 5 pi over 4, 7 pi over 4. There are multiple ways I can go about saying what it is. One of those ways is pi over 4 plus n pi, meaning we keep adding a pi every time, and we're going to get to positive 1. Or we can do 3 pi over 4 plus n pi. We're going to keep hitting those same values, those same 4 values we're going to hit over and over again throughout. Of course, it's for all integers n as well. Now we're going to find all solutions on the interval from 0 to 2 pi, including 0. 0 and 2 pi, remember, hit the same value, so we're just going to include 0 and not say 2 pi if that's the answer. So we've got 2 sine x cosine x equals root 2 cosine x. So these problems, when you see multiple trig functions, either you can simplify something, or you're going to have to factor. In this case, you're going to have to factor. I'm sorry if you don't like factoring. But you're going to have to like factoring in this section. So we'll subtract root 2 cosine x to both sides. Give me 2 sine x cosine x minus root 2 cosine x equals 0. Now that we have set equal to 0, we can factor. Is there a common factor between these two terms? You betcha. That's cosine x. So I'm going to have cosine x parenthesis 2 sine x minus root 2. Set both terms equal to 0. So I have cosine x equals 0. And I also have 2 sine x minus root 2 equals 0. Scroll down here so I have a little more space. When is cosine x equal to 0? It's equal to 0 at pi over 2 and 3 pi over 2. Because those are when the x values are 0. Here we're going to simplify a little bit, given so we're going to get 2 sine, that's twice. 2 sine x equals root 2. Divide by 2, you get sine x equals root 2 over 2. And when is sine x equal to root 2 over 2 between 0 and 2 pi? That's at pi over 4, 3 pi over 4. So your solutions are these two and these two. Now there's overlap in any answers, which could happen. You will just take one or the other. Also, sometimes you might get one of the factors are impossible and there's no values in your unit circle, then you just don't have to worry about solving that anymore. And just focus on the other factor. This one looks like a mess. Find all the solutions. Once again, looks like we have another factoring problem. What type of factoring? We have 4 terms here that can't simplify, right? So what factoring method do you think we should try? There's 4 terms. We should probably try grouping. It's too bad the cosines in the middle couldn't simplify at all. So GCF of these 2 terms is going to be 2 cosine x, leaving me inside of 2 cosine x plus 1. Negative root 2, leaving me with 2 cosine x plus 1. As you can see, that exactly the same factoring rules, just that we have a trig function as well. No different. So I can factor out that 2 cosine x plus 1. And my leftovers are 2 cosine x minus root 2. Set them both equal to 0. And then what happens? Well, isolate your cosines. And when we do that, divide by 2, you get cosine x equals negative 1 over 2. And so we need to ask ourselves, when is cosine equal to root 2 over 2? And when is cosine equal to negative 1/2? Well, cosine is equal to negative 1/2 at 2 pi over 3 and 4 pi over 3. Use your unit circle, folks. Where is cosine equal to the root 2 over 2? That's at pi over 4 and 7 pi over 4. And there's all your solutions. Because we just asked for from 0 to 2 pi. Alright, these last two might be arguably the most difficult of the bunch, but key thing is we need to be able to factor them or simplify them so we can solve them. So this one here on the left, set equal to 0, just like the others. Subtract 2 sine squared x to both sides, give you negative 2 sine squared x minus cosine x plus 1 equals 0. I can't factor unless we have all the same trig functions. So how can I make sine squared x the same trig function? Well, if I do 1 minus cosine squared x. Now, if I distribute negative 2, I'm going to get 2 cosine squared x minus cosine x plus 1. I mean, like terms, yeah, let's take care of that negative 2. So we're going to get 2 cosine squared x minus cosine x minus 1, because negative 2 plus 1 is negative 1. Now, what factors of negative 2 that of negative 1 is negative 2 and 1? If you don't remember how to factor, you're in big trouble. I'm sorry. Factoring never went away. And grouping, group, 2 cosine x, parenthesis, cosine x plus minus 1 rather. And then GCF that other one is 1. I'm going to do an equal sign, my apologies. So plus 1, parentheses cosine x minus 1. And factor out the cosine x minus 1 equals 0. 2 cosine x plus 1 equals 0. We're going to talk about when cosine x is 1 and when cosine x is negative 1/2. When is cosine x 1? Keep in mind, 0 is included, but not 2 pi, so just 0 is going to be your answer there, because cosine 0 is equal to 1. So it's 2 pi, but 2 pi, remember, is not in our interval. When is cosine x equal to negative 1/2? We did that fairly recently. It's 2 pi over 3 and 4 pi over 3. And finally, we have secant x plus 1 equals tangent x. What an ugly problem. Okay, so what I'm going to do here is square both sides. And when you do that, you need to FOIL the left side, and you're going to get secant squared x plus 2 secant x plus 1 equals tangent squared x. Now remember, our goal with this is we need to get all the same trig function. Is there anything we know about tangent squared x that will get us the same trig function as secant? As you probably should know, 1 plus tangent squared x is equal to secant squared x. So I'm going to replace tangent squared x, keep the left side the same for now. Oops, we don't want that. That's better. Secant squared x plus 2 secant x plus 1 equals, if we move that 1 over, you'll get secant squared x minus 1 using our Pythagorean identities. Now let's move everything to one side so we can be able to factor. It's going to give us 2 secant x plus 2 equals 0.
Yo! Hello, Precalc. I hope you guys have a great video. Mr. Barton teaches you guys so much.
Yes, sir. And that was some special guest that wanted to be part of the video. You see me when I'm recording. You can too, as long as you don't say anything absurd. So, anyways, we had 2 secant x plus 2 equals 1. So let's simplify. Subtract 2. 2 secant x equals negative 2. Divide by 2. Secant x equals negative 1. When is secant equal to negative 1? So you're thinking, when is my x value negative 1? Your x value is negative 1 only at pi. And that is your answer. Appreciate you watching, and we'll see you in class. Bye-bye now.